I'd like to dive into a little bit more detail on the whole issue of how does design data flow and change over the full range of the design flow. And part and parcel of that then is what are the areas that today you should be concerned about when it comes to achieving design productivity, and what are the areas in the future that we believe are going to be areas of equal concern. Just to start very briefly, of course, most of you start with an RTL description of the design and perform functional verification on that. And so that initial logic verification is going to be essentially dealing with relatively limited data. We see most RTL code bases as being relatively small. I'm going to say megabyte or below. But as you can imagine, what happens during the design flow to the data is this. So as you go through synthesis, physical implementation, physical design, and then down into physical verification, what you're going to find, of course, is that the data sizes start to really expand. So again, to put some real numbers to it, this is where we're seeing most of the file I/O related issues happening, is in physical verification, partly because the amount of data that's generated and needs to be analyzed is quite large at that point. You have all the routing, you have all of the placement of elements in the design, and you have actually a lot of design for manufacturability and resolution enhancement technology that's already been applied. But in addition to the actual design database itself, you're also at this stage applying a lot of rules. And that's the other thing that's dramatically changed over the last few years. So typically, if you looked at 65 nanometers versus twice that, 130 nanometers, you didn't see a doubling of the number of rules that had to be applied. You actually saw something quite significantly more than that. Because not only did you see more design rules having to be applied, but new forms of design rules. So, for example, resolution enhancement brings along its own set of design rules that have to be checked during physical verification. Similarly, as people do more design for manufacturability and yield analysis and yield enhancement, that would also add to the rule deck that has to be applied to the overall physical database at this stage. Many of you might even ignore recommended design rules from the fab that you're working with or from your ASIC vendor. And those design rules, of course, equally contribute. So we've seen not just a doubling going from from 130 nanometers down to 65, we've seen probably a 3x increase. And so all of that conspires in this phase of the design process to create some significant I/O bottlenecks, and also to make the scale and size of data that has to flow between the tool and your compute environment significantly different than it ever has been before. Now let me put a specific number and way to look at this problem here in front of you. If you look inside your log files and take a look at the elapsed time versus CPU time, it's probably a good indicator of where you're going to find file I/O related issues. And again, to put a real number to it, what we've seen is that as you progress through the design flow, you might start with anywhere between a 1 to 3 ratio up at the very beginning stages. Sure, there may be some network latencies, there may be some file I/O related issues, but relatively small and minor. Your CPU time is roughly equivalent to your elapsed time, and that's obviously a good thing. As you progress through, that ratio starts to become bigger and bigger according to the amount of data and the amount of file operations that have to take place. To put a real number to it from a customer of ours, when they got to DRC in the physical verification phase, the design rule checking phase, they found a 20-to-1 ratio of the elapsed time versus CPU time. And that's a problem that we were able to solve. We're able to take in the DRC phase for this 65 nanometer design, we're able to shave close to 50% off of the runtime in the DRC operation. And we're working with that customer to improve upon that even further. So as you can imagine, that 20-to-1 ratio is really a signal to you as the IC design team to look there for where your file-related issues are going to be and where storage can become a key contributor to your overall design productivity.